Alcohol and human health. Is there any benefit? This is the video for anyone out there who's drinking alcohol and wondering that question, as well as those of you who know the answer but justify that just a little is okay. So let's dive into that today. If you've ever said a little is good for you or everything in moderation, those may be statements that signify that you have a drinking problem because you're justifying your addiction. I say that a little tongue in cheek, but it might have a little truth to it. And I'm going to show you the research today that shows that both of these statements are false in regards to alcohol consumption regarding health. And so we'll start with a recent study that came out in 2024, and the lay press article reporting on it. So the lay press article stated moderate drinking is not good for you after all, study finds. And its subtext is studies that suggest alcohol can be good for you in moderation and even extend your life may be based on flawed research methods, according to a team of scientists bent on setting this ubiquitous misconception straight. And to the right, you can see the paper written by Tim Stockwell and colleagues. And if you've read the lay press about alcohol, you may be confused as to whether it's good for you or not good for you at low doses. I think everyone understands that it's not good for you at high doses or in the form of binge drinking, but there's conflicting evidence in the research and in the lay press for sure about whether moderate or low level alcohol consumption can have some benefits for you. So this paper sought to tease out those inconsistencies and try to find the truth. And the way that they did that was they performed a systematic review and meta-analysis of 107 longitudinal studies. And those sound like nerdy words, but it's important that you know that because systematic reviews and meta-analyses allow researchers to take many studies and statistically find the flaws and the truth in the research. So this paper took 107 longitudinal studies that looked at alcohol consumption and all-cause mortality or risk of death from all causes. And the combined number of participants in those 107 studies was over 4.8 million people. Having millions of study subjects allows for statistic significance to be determined. And what these authors did was they took those 107 studies and they divided them up into high quality studies and low quality studies. And the devil is in the details there, because if you eliminate the low quality studies, any benefit to any alcohol consumption was eliminated. And so the studies and the news articles based on those studies that say a moderate amount of alcohol or a low amount of alcohol is good for you and maybe even promotes longevity, those are all wrong due to low quality of the study. And so what is high quality and low quality? If we dive into the body of the lay publication here, we can understand that more clearly. So I quote from the article: the researchers stratified the different studies. This stratification weeded out studies affected by what's called abstainer bias. Abstainer bias is where a person was included in the control group because they abstained from drinking alcohol. But putting abstainers in a control group can be misleading because the low quality studies included people as abstainers as those who had a history of drinking, but they had since stopped drinking. And so including the people who had a history of long-term drinking, who quit drinking, perhaps for health reasons, and including them in the control group skews the data because they don't represent long-term abstainers. So comparing the longevity of a one wine a day drinker with that of a now sober but long-term alcoholic isn't the same as comparing a moderate drinker with someone who's never drank, right? Studies where participants are older are more likely to be affected by this issue since there's more lifetime within which current abstainers may have once been drinkers. accumulating associated health issues that throw off the average all-cause mortality in the abstainer group. So the author, Tim Stockwell, said that makes people who continue to drink look much healthier by comparison. So if we walk through it again, basically a control group is in the context of these alcohol studies, the control group should be made up of all people who don't drink. And specifically, it should be abstainers, so people who have never drank. But the low quality studies in the control group include people who have never drank and people who no longer drink. But the people who no longer drink skew the statistics because they may be no longer drinking because they used to drink so much that they have health issues from it now. And so looking at them as non-drinkers and their health issues being included in that group brings them more equal to the drinking group that also has health issues. So you could see how it would skew the numbers. And so the low quality studies included that. The high quality studies did not include those people. And when you get rid of the low quality studies and look at only the high quality studies, you find that even the low volume alcohol drinkers have increased risk of death from all causes. So no, just a little bit is not good for you. Here's another paper done by the Journal of the American Medical Association looking at the association between daily alcohol intake and your risk of death from any and all cause. If we look at their paper, they ran a meta-analysis. This is a paper by the same group, Stockwell and colleagues. And what they found was all-cause mortality for drinkers who drank less than 25 grams of alcohol per day, which is about 2 Canadian standard drinks, compared with lifetime non-drinkers. There was no difference in reductions of all-cause mortality. There was a significantly increased risk of death among female drinkers who drank 25 or more grams per day, and among male drinkers who drank 45 or more grams per day. So low volume alcohol drinking was not associated with protection against death from all causes. So again, a different way to say it, but no amount of alcohol is protective. So there's no justification for consuming it in terms of, oh, I'm just doing it to promote longevity or to get the health benefit. There isn't one. Well, how does alcohol damage us then? Okay, so we realize, okay, here's 2 papers showing that there is no benefit, but okay, if there is no benefit, how is it hurting us? This paper is showing that intestinal permeability, the nerdy name for leaky gut, and gut bacteria dysbiosis are imbalanced in good bugs and bad bugs, and behavioral markers for alcohol dependence are connected. So they start by saying alcohol consumption is the world's 3rd largest risk factor for disease and disability and accounts for almost 6% of all deaths worldwide. That's big time. So drinking alcohol is the 3rd largest risk factor for disease and disability. And then 6% of deaths worldwide are caused by alcohol. There's 8 billion people worldwide. So 6% of whatever percentage of those people die each year is a large number. Alcohol dependence has traditionally been considered a brain disorder. Alteration in the composition of the gut microbiome has recently been shown to be present in psychiatric disorders, which suggests the possibility of gut-to-brain interactions in the development of alcohol dependence. We found that some, but not all, alcohol-dependent subjects developed gut leakiness, which was associated with higher scores of depression, anxiety, and alcohol craving after 3 weeks of abstinence, which may be important psychological factors of relapse. Moreover, subjects with increased gut permeability or leaky gut also had altered composition and activity of the gut microbiota. So look at that. Okay, so one way that alcohol damages us is it causes imbalance in our good bugs and it causes leaky gut. And then that imbalance in the microbiome can drive psychiatric disorders and alcohol dependence. So the significance in the blue box there, they say alcohol dependent subjects frequently develop emotional symptoms that contribute to the persistence of alcohol drinking. These subjects are also characterized by GI disturbances. We showed that alcohol dependent subjects with altered gut permeability had also altered gut microbiota composition and activity and remained with high scores of depression, anxiety, and alcohol craving after short-term detoxification. These results are consistent with the existence of a gut-brain axis in alcohol dependence, in which the gut microbiota could alter the gut barrier function and influence behavior in alcohol dependence. Therefore, this study opens a previously unidentified field of research for the treatment and management of alcohol dependence, targeting the gut microbiota. So, boom, could someone with alcohol dependence benefit by taking probiotics? Potentially. They'd probably benefit even more if they took probiotics, cleaned up their diet, cut alcohol, and promoted strategies that heal the gut from many angles. How else might alcohol damage us? This paper, acute binge drinking increases serum endotoxin and bacterial DNA levels in healthy humans. Alcohol binge drinking is defined as more than 4 drinks consumed at once or in a sitting. Okay. So alcohol binge drinking, defined as more than 4 drinks consumed, is the most frequent form of alcohol consumption worldwide. Hear that? So the most common way to consume alcohol is to binge drink it worldwide. This drinking pattern is popular among underage drinkers and young adults, leading to increased mortality and morbidity, so increased death and disability. Binge drinking, the most common form of alcohol consumption, is associated with increased death and disability. Chronic alcohol use results in increased gut permeability or leaky gut and increased endotoxin levels in the blood that contribute to many of the biological effects of chronic alcohol consumption, including alcoholic liver disease. Acute alcohol binge drinking resulted in a rapid increase in blood endotoxins, a marker of bacterial translocation from the gut. So translocation is bacteria leaving your GI tract and entering the body through the gut wall, and now setting off fire alarms. Because remember, behind that gut wall is 80% of the immune system. Those bacteria should not make it that deep into our body. And so when they do, that drives systemic inflammation and immune response. Compared to men, women had higher blood alcohol and circulating endotoxin levels. In addition, alcohol binge caused a prolonged increase in acute phase protein levels in the systemic circulation, which are inflammatory markers, as well as tumor necrosis factor alpha and IL-6, which we've talked about many times in many videos as being 2 of the 3 or 2 of the unhappy triad in terms of inflammation. And that triad is TNF alpha, IL-6, and IL-1 beta. So in purple, even a single alcohol binge, so a single night of 4 drinks, even a single alcohol binge results in increased bacterial endotoxin levels in the blood due to translocation or crossing of the gut by bacterial products, and disturbs the innate immune system, which can contribute to the deleterious effects of binge drinking. So the previous study said alcohol consumption drives leaky gut and disrupts our bugs and can impact alcohol dependence. This paper said acute binge drinking drives endotoxin levels in the blood higher by letting bacteria into the body, driving systemic inflammation. And again, how did they create this? Down on the bottom right, they took healthy individuals, so 11 males and 14 females, ranging in age from 21 to 56, with no history of alcohol use disorder, okay, or no alcohol dependence. And they gave those healthy individuals, well, first they made them all avoid alcohol for at least 48 hours. And then they gave them 2 milliliters of vodka in 300 milliliters of orange strawberry juice. Okay, so it was just two milliliters. So a tiny amount of vodka drove the endotoxin increase and bacterial increase in the systemic inflammation. So it doesn't take a lot. Again, low volume is not healthy. Here's a paper from 2017. The quantity of alcohol drinking positively correlates with serum levels of endotoxin. So again, what is endotoxin? Endotoxin is also called lipopolysaccharide or LPS, and it is made by gram-negative bacteria. So gram-negative bacteria release LPS, and that is one way that they drive inflammation and damage us. Examples of gram-negative bacteria include E. coli, Salmonella, Pseudomonas, Citrobacter. There's lots of them. Helicobacter pylori or H. pylori. There's many of them. Okay, so the amount of alcohol you drink correlates with the amount of endotoxin entering your body. And as we saw in the last study, the way that endotoxin gets in is the alcohol drives leaky gut and allows the bacteria to cross that gut barrier and their metabolites to cross it. So in this paper, they took 148 subjects. 97 were considered excessive drinkers and 51 controls, so non-drinkers. And they measured the level of LPS or endotoxin in their blood, as well as a couple other immune markers. And what they found was, compared to controls, the excessive drinkers had higher drinks in the last 30 days, obviously, and they also had higher levels of LPS and immune markers. The levels of endotoxin in the blood were higher among the excessive drinkers compared to those who don't drink. A positive correlation between the LPS and the quantity of alcohol drinking was found. Abstinence was associated with a decline in the levels of LPS and immune markers. So the good news there is the drinking drives it up, but abstinence allows them to come back down. So if you're someone who has a history of drinking and you see this information and you no longer want to drink and you start becoming an abstainer, right? Or you become sober, well, then over time, these levels will come down. The gut barrier can heal. You can promote a healthy microbiome, and you may be able, depending on where you are and how long you've been drinking and how much, you might be able to eliminate your risk of chronic disease. If you're too far along, you might not be able to eliminate the chronic disease you've developed, but you might be able to significantly reduce symptoms and maybe even reduce the severity of the disease. So in the bottom, endotoxin is the key factor in the pathogenesis of alcohol-induced liver injury. Excessive alcohol consumption leads to the impairment of the gut barrier, or leads to leaky gut, and subsequent bacterial crossing from the gut into systemic circulation. Once in circulation, the endotoxin can bind to immune receptors and drive inflammation. Akkermansia, mucinophilia, and alcohol-related liver diseases. You've heard that name before, Akkermansia, mucinophilia. We dedicated its own video to it a couple months ago, because this is the current, in 2024, this is the current darling of probiotic research. And it's been shown to promote healthy body composition, healthy cholesterol metabolism, healthy insulin sensitivity, and healthy gut barrier integrity. Let's read. Akkermansia mucinophilia are gram-negative commensal bacteria. They degrade mucin or mucus in the intestinal mucosa. They modulate gut barrier integrity, and they modulate inflammation in the digestive tract, liver, and blood. Lower levels of Akkermansia are more commonly found in people with obesity, diabetes, metabolic syndrome, or inflammatory digestive diseases. We've said that before in the previous video. But look at the red. Overconsumption of ethanol, which is alcohol, can also induce a decrease in Akkermansia. And that decrease, so lower Akkermansia levels caused by intake of alcohol, is associated with dysregulation of the probiotics, with leaky gut, with chronic inflammation, and production of cytokines, which drive inflammation. So at the bottom, several studies have shown that supplementation with Akkermansia can improve alcohol-related liver pathology and highlight the interest in using this bacterial species as a probiotic. Again, another mechanism by which alcohol damages our body is to drive dysbiosis and damage probiotics. And here's a specific strain that's shown to be damaged. So the alcohol damages us directly by driving dysbiosis and driving leaky gut and driving inflammation and driving liver dysfunction. But it also, part of that direct impact is by specifically driving down Akkermansia levels. And that might also impact or contribute to how alcohol drives or contributes to diabetes and blood sugar disorders as well. So looking at the other way, how could we, if we become an abstainer and we quit alcohol and we want to heal our gut and heal our body, one thing we need to do, as we saw, is promote a healthy gut microbiome. And well, what probiotics should we take? This study shows us that specifically Akkermansia is one that we want to make sure we replete. Aldehyde dehydrogenase 2 deficiency increases susceptibility to binge alcohol-induced leaky gut, endotoxemia, and liver injury. So aldehyde dehydrogenase is an enzyme that our body uses to detoxify alcohol. When we consume alcohol, which is in the form of ethanol, the body has to convert it to a toxic metabolite called acetaldehyde, and then convert it to acetate to make it less dangerous. Okay. And this enzyme is involved in that conversion. And so in your mitochondria, this is one of the players. And so you can see mitochondrial aldehyde dehydrogenase is the major enzyme responsible for metabolizing toxic acetaldehyde from alcohol to acetate and acts as a protective or defensive protein against various disease states associated with alcohol use disorder, including alcohol-related liver disease. A deficiency in this enzyme increases the sensitivity to binge alcohol-induced oxidative and nitritive stress, so rust, gut cell death, and breakdown of gut tight junctions, which promotes leaky gut. The elevated level of endotoxin in the blood and the bacteria crossing into the system causes systemic inflammation, liver cell death, and subsequent acute liver injury through the gut-liver axis. All these findings demonstrate the critical role of aldehyde dehydrogenase in alcohol-induced leaky gut and suggest that a deficiency in this enzyme or gene mutation in humans for this enzyme is a risk factor for alcohol-mediated gut and liver injury, and this could be an important therapeutic target. Okay, so that's a mouthful. One thing to know is that there's genes that code for this enzyme. So you could test your genes and understand, do you have a mutation in this gene which reduces your ability to efficiently detoxify alcohol? If you do, then you definitely don't want to drink alcohol, because then all the negative effects of it are exacerbated. But say you don't have a genetic issue, why else might you have insufficient aldehyde dehydrogenase function? We've talked about this enzyme in the past in regards to its role in histamine and reducing histamine and preventing histamine-based disorders. And aldehyde dehydrogenase is an enzyme, which means it's a protein that does work. And its work is, one of its jobs is to detoxify alcohol. Well, the proteins that make up enzymes all have nutrient cofactors that they require in order for them to work. So in regards to aldehyde dehydrogenase, it requires iron, vitamin B2, vitamin B3, and molybdenum to work. So if you had an insufficient amount or a deficient amount of any of those four nutrients, then you might have poor aldehyde dehydrogenase function, poor detoxification of alcohol, and be promoting the leaky gut and systemic inflammation, liver damage due to the nutrient deficiencies. So those people, if they improve their iron, B2, B3, and or molybdenum status, that would help them better detox alcohol and reduce the risk of those things. But the better answer would be to cut out alcohol altogether, optimize their nutrient levels for that enzyme, and move forward without the stress of the alcohol. How about your brain? What does alcohol do to the brain? Here's a paper from Nature looking at the association between drinking alcohol and the impact on gray and white matter levels in the brain. And this looked at a database of over 36,000 adults in the UK. Heavy alcohol consumption has been associated with brain atrophy, so brain shrinkage, neuronal loss, and poor white matter fiber integrity. So right there, alcohol consumption is associated with shrinking your brain, losing neurons. Well, what happens when you lose neurons? A shrunk brain and neuronal loss promotes dementia. So alcohol associated with dementia, okay? So looking at 36,000 middle-aged, healthy middle-aged and older adults from the UK, we find negative associations between alcohol intake and brain macrostructure and microstructure. Specifically, alcohol intake is negatively associated with global brain volume. So the more alcohol you take, the smaller your brain, or the more shrinkage. We show that the negative associations between alcohol intake and brain structure are already apparent in individuals consuming an average of only 1 or 2 daily alcohol units, and become stronger as alcohol intake increases. So again, if you jump to the right, well, what's an alcohol unit? A large amount of alcohol in females is considered 18 units or more a week, and male is considered 24 units or more a week. That's a large consumption. Well, they said at the bottom of the picture on the left, we show negative associations with an average of just 1 or 2 daily units. So very low volume. So again, there's no protective effect, and even low amounts are bad. Alcohol consumption is one of the leading contributors to global burden of disease and to high healthcare and economic costs. Alcohol use disorder is one of the most prevalent mental health conditions worldwide, with harmful effects on physical, cognitive, and social functioning. Chronic excessive alcohol consumption is associated with direct and indirect adverse effects, including but not limited to heart disease, nutritional deficiencies, cancer, and accelerated aging. Chronic alcohol use is associated with changes in brain structure and connection. Neuroimaging studies have shown that chronic heavy alcohol consumption, defined as 3 or more drinks for women and 4 or more drinks for men on any day, is associated with widespread patterns of large and small structural changes, primarily affecting the frontal, diencephalic, hippocampal, and cerebellar structures. So all the important structures of the brain are impacted by alcohol consumption. Alcohol and the brain-gut axis. We're almost done, but this is going to show it to you in a picture here as regards to the brain. Binge or chronic alcohol consumption causes neuroinflammation. Boom. And leads to alcohol use disorder. Alcohol use disorder not only affects the central nervous system, but also leads to pathology in the peripheral and enteric nervous systems, or gut nervous system. Growing evidence shows that excessive alcohol consumption can activate neuroimmune cells, including microglia, and change the status of neurotransmitters affecting the neuroimmune system. So again, drinking impacts neurotransmitter status. Well, if you have anxiety or depression or insomnia or pain, one of these things connected to neurotransmitter physiology, and you're drinking alcohol, you got to cut it out. Microglia are integral parts of the immune defense in the brain. Microglia constantly survey the central nervous system to scavenge the neuronal debris. Okay, so what they're doing is they're looking at the nervous system and saying, is there any trash out there? And if they do, they scavenge it or clean it up. And the reason for that is if you leave trash in the brain, it accumulates, right? Just like if you leave trash on the street, and it's just like you don't like to see litter in your environment, leaving litter in the brain is pro-inflammatory. So microglia scavenges for trash to keep the nervous system healthy against infection and stress-derived agents. Several receptors on microglia respond to the inflammatory signals that arise from trash in the brain, and alcohol is one of those stress-causing trash molecules. So here's a picture from this study, and what we're looking at, that gray blob there, is looking at your brain from the side. And if we take alcohol and we put it in the brain, all right, at first in a healthy brain, resting brain, you have a resting microglia. So this is a healthy microglia just surveying for trash, doing its job. It's not activated, it's just hanging out. Okay, but you add a stressor to the brain like alcohol, which crosses the blood-brain barrier. Now that alcohol stimulating the resting microglia leads to an activated microglia. Activated microglia use inflammation. They're the immune cells of the brain, so they're going to take action. And what does the immune system do to clear debris and kill infection? It produces inflammation. So alcohol turns macroglia on, which now become inflammatory, and then you have neuroinflammation. You have an increase in the devil's triad of inflammatory markers, TNF-alpha, IL-1 beta, IL-6, and others, and you have a decrease in the anti-inflammatory messengers of the brain. So we don't want to be consuming alcohol and turning the brain on fire, because a brain on fire promotes anxiety, depression, seizure, migraine, excitotoxicity, which leads to dementia, neurodegeneration, Parkinson's, etc. All right, so we don't want that. And an activated microglia can lead to neurotransmitter imbalances as well, as we said. So it's very important to cut alcohol out if your goal is to be healthy and live a long, healthy life. There is no level of healthy alcohol consumption. And I hope that this research has helped establish that fact in your mind for you, so that next time you're at a wedding or a bar or a football game or something and someone says, come on, man, just moderation, or a little bit won't kill you, you can print these off and say, actually, it will and is. Just one day of binge drinking 4 drinks here while the game's on is creating leaky gut and gut dysbiosis and systemic inflammation. So, spread the news, change your lifestyle. You have the power to improve your health by just saying no, like your dare officer told you in elementary school. All right, let's open it up for questions.
Dr. Bartemus.
Yeah.
So if you stop drinking, is there like a certain amount of time where these effects are no longer taking place?
Good question.
Yeah, to these side effects are no longer taking place.
Yeah, there's the study, the one that talked about abstaining. Abstinence was associated with a decline in levels of these things. Different studies say from 2 to 6 months of abstinence leads to significant, changes going the positive way.
Okay. So years can make a difference.
Oh yeah.
Okay.
Yep. Yeah, good question.